Tell me about how we got to this.
We started working with some government programs, and it wasn't a bad idea. It just has to be done differently.
You are talking to some amazing innovators today. The product today that we're talking about comes all the way from one of the largest aerospace defense contractors in the United States. What is Insofast? How do we come up with that name?
Like all good names, it was a mistake. We were actually talking about...
We obviously started with the Insofast panels, which are a very quick way to throw up insulation on a wall.
People have been using shipping containers for everything, housing, shops, woodworking facilities. This has amazing fit with the container people.
There's a lot of products out that aren't attainable for the everyday market. We're not all building $4 million homes.
Be fitted out for a $4 million home, $2 million home, whatever it's going to be. This is giving you that $4 million performance without the price tag. Well, hello, everybody. It is Mike with Spray Jones and Think Spray Foam. We've got another podcast here today where we are talking about American innovators, creators, inventors, and this is an amazing American family. They have been working in the insulation and building envelope for a long time, 2006, and they don't just stop with one or two good products. When they see a need, they fill in and create. You are talking to some amazing innovators today. In fact, the product today that we're talking about comes all the way from the aerospace industry. One of the largest aerospace defense contractors in the United States gave them a helping hand. Why? Because their son works for them. We can't disclose it. It's redacted exactly where it's coming from. But today we have got Ed and Matt, father and son duo of Insofast. You might have seen these guys for the last couple of years now. They have been tearing up the internet with their X-bracket system on the outside of buildings. And of course, it's a perfect use with spray foam. So that's why we're here to talk to them today about this system. And they're going to fill us in on all the details, the who, what, when, and where, and why, and where things are going. So welcome into the studio today, Matt and Ed.
Yep, thank you. We're glad to be here.
So what is Insofast? How do we come up with that name?
Well, like all good names, it was a mistake and mishearing of what some of the names were. We were actually talking about Insofast, so insulation fast, and it was misheard as Insofast as being a good name by my father, and said, well, that Insofast is really a great name. And I said, what? What do you mean? He said, well, you said it. So that's kind of the background behind it.
That's interesting. And sometimes the happy accidents come out and then people are like, nah, let's just stick with it. Let's roll with it. I mean, I took the Spray Jones name off of Indiana Jones because I just wanted something simple for the people to understand about foam. I didn't want some complicated name. Ed, you've been in insulation for a long time. Tell us about how you got started with that and how the Insofast came to be from Insofast.
Yes. So we were always builders, and small builders would build a house. I was always interested in super energy efficiency and making things better. My first experience with continuous insulation as a builder was 1992 when we decided to do our own house. And we did 2 inches of polyiso with 2x4 framing.
Okay.
And as a builder, I picked out the polyiso because it was the highest R value per inch, not knowing anything about it. And the biggest mistake we made was putting fasteners all the way through the insulation into the studs.
Right.
Because it created a thermal bridge.
Yep.
Especially when we were a little bit on a budget and we decided to do vinyl siding with long roofing nails penetrating through. And what we found out was that nails showed up like galvanized nails on cedar siding just because there was so much heat flowing through it because of all the insulation. So the more of the insulation, the more heat flow because the stud would be warmer from the insulation. So that's when I started learning about building science and the whole dynamics behind the heat flow and the thermal bridging. And that's what brought me into looking at the insulated concrete forms in the mid-90s. And we did homes with that. And because of the concrete, you stopped the airflow in there and you had the insulation. But what we found out, I mean, it was only as good as the install crew.
Right.
And you'd get a crooked wall, it's cast in concrete.
Oh, absolutely. Yeah.
You'd get a good installer, and then the next job they did, they had issues with. So it was that inconsistency, and the overall concept was good. So that's how our Insofast panels were born. From that, we basically took the front faces of the insulated concrete form. I should say we took all the technical aspects as far as how to build it and do it and get a straight wall. We didn't have to deal with that anymore. We dealt with the existing wall and we went right over that and didn't have any of the blowouts or any of the things associated with that. But it never became mainstream. It was never easier or quicker. At the time, people would advertise, well, it's 2 to 6% more than regular. Well, it was really 25% more when you started looking at concrete compared to a pile of studs. And it was just never going to be mainstream. So back to wood framing and reformed ICF, because it really is, insulation is addictive in here, and trying to get performance is really addictive. When to stop with it. And what we've found, I mean, the issue with the framed wall is being able to get continuous insulation over it, and continuous insulation without thermal bridging, and be able to stop the airflow. And the science behind it is really, the spray foam is the air barrier.
Mm-hmm.
That's complete. We're not just dealing with filling stud cavities anymore with half a mile of seams. We're seamless and monolithic. So it also serves as a water barrier. It's waterproof, and it's a continuous unbroken thermal barrier as well as the sound barrier. So
I got a question going back. When you were doing the insulation to the outside and you realized the thermal bridging with the galvanized nails, and you were sticking them through the insulation into the wall, were you finding that was directly contributing to moisture problems then behind the insulation?
I would say not. It was really just a thermal short circuit in there. So the biggest issue we had, not only with the nails, was with the foam shrinking.
Oh, really?
You could actually go through, we had meticulous tape seams with, at the time it was 3M red tape. Now they have all sorts of European tapes and so forth.
Yep.
But literally that just snapped and broke and was completely broken, and you could stick your fingers in and touch the framing. So the area you wanted insulated the most had no insulation at all.
This was just what, a dimensional stability issue? Like the insulation was actually staying one size and the building was moving independent of the insulation? Is that what was going on?
Well, actually, it's the foam board itself shrinks because it's not bonded to anything.
Oh, wow.
The entire foam board shrinks. And it's not uncommon on roofing applications for them to pull up roofing applications and see a 1-inch gap in the insulation from where it was fit tight. It's actually shrunk.
How many people know that, Ed? Like, you see people all the time that are cladding and using rigid insulation on the outside of their buildings and their structures. Do they know what it's going to be doing, do you think?
Well, that's the building science behind it. Yes, they do know that. And that's why they stagger seams on all the boards so it doesn't have a direct path through.
Wow. Well, just what I mean is, okay, you're staggering the seams, but you're still agreeing that this is going to be an ongoing issue. You're just sort of, mitigating it by, okay, well, we'll stagger the seams. At least it won't be a total loss, but we're still going to have it. Wow. I bet you a lot of people, like, I'm not talking about architects and engineers. I'm just talking about the average person doesn't realize just what's going on. They install it and don't realize what you came to understand, seeing what it's moving, how much it's moving around, I bet you. It's kind of scary, actually.
Right. And they'll say it can shrink up to 1%. Now, most of that shrinkage is done before you get it. So if you get brand new foam, you're going to have more shrinkage than stuff that was sitting there for 6 months as well. So
that's interesting. So then you pursued what? You had moved into a bunch of different panel products. You had exterior buildings. You were selling the Insofast stuff for containers, sort of the lead up towards where the X bracket comes into the conversation.
We obviously started with the Insofast panels, which are a very quick way to throw up insulation on a wall. It's simple as just screwing in there. You don't need any furring strips going in front of it like most other insulation assemblies.
Right.
And if you're going to a concrete wall, you can even just glue it to the wall, which is even faster than screws. And that is a great product. It's got the built-in studs. It's got EPS insulation, which we chose that intentionally. A lot of people ask us why we didn't go with other types of insulation, like polyiso or XPF. The reason is it's an inert foam. That shrinkage issue is a lot less prevalent in EPS. It's expanded with water, a lot less environmental impact than other types of foam. So when we were starting to think about the X-bracket system, we had in the past had people ask about using our Insofast studs with spray foam, just gluing them to the wall. We kind of discounted that for a little while because it didn't really make sense from our business model.
Right.
But then we started working with some government programs and University of Minnesota, and we decided that it wasn't a bad idea. It just has to be done differently. So we started doing the engineering for designing these X brackets with actually my brother, aerospace engineer, basically. And he started doing mock-ups and testing. And we came to our original prototype, which didn't look exactly like that. It had a square face.
Right. It
was different size, and the electrical clips on there that are going to look a little different on the newer ones. We did our first house with the X bracket in South Dakota. It was property we owned. It was a garage, actually not a house, because we already did the house with our panels. And we just started putting them on, figuring out details, how it works in the field. It went surprisingly well. When we started developing the X bracket system, we had some people asked about using the embedded studs that are in our EPS panels for spray foam applications. We kind of discounted that for a while because we didn't think it really made sense from a business model. I mean, we sell foam boards. We don't sell spray foam products. I kept getting occasional questions like that, and then we just gave it a little bit more thought. We collaborated with some government programs and some people at the University of Minnesota, just kind of bounced ideas off of them. And then we ended up coming up with our X brackets that are designed to completely eliminate thermal bridging in a spray foam assembly.
Right.
Which the thermal bridging gives a substantial hit when you're spraying insulation between the studs. And that hit is amplified when you start adding more insulation. For example, if you're doing R30 spray foam in a 2x6 framed wall, like a lot of builders in the Northeast are doing to meet the 2021 building codes, they are actually going to end up with a wall that performs at around about R16 instead of the R30 that they sprayed. So taking the thermal bridging out of it entirely is a huge advantage to our system. I'm going to show you something quick right here. I have two fasteners. As we were talking about the foam boards and the screws going through the foam boards, I don't know if you can really see this, but this is a 1/4 inch structural screw that you'd see used all the time in foam board assemblies. This right here, I kind of doubt you're even going to be able to see this very well. This is a 16 gauge finish nail that you would use to attach a baseboard to a wall typically. The truth is, the material that this bracket is made of is 250 times less conductive than steel. If you were to equate this bracket to steel, you'd have approximately a 16 gauge finish nail.
Wow.
So almost nothing.
Nothing.
On top of that, when we're talking about putting these 1/4 inch fasteners through the foam board, it creates a substantial thermal bridge. Steel is typically thousands of times more conductive than the insulation that you're putting on your wall. In effect, when you put this through your insulation, you might as well take a 4-inch hole saw and cut out a plug of your insulation. It can affect it as much as 5 to 10% when we're talking about the thermal bridging true fasteners. So when we're using the bracket with the spray foam, we're getting even more superior, just from an insulation standpoint, a superior wall assembly that will actually give you the R value that you're spraying.
Right.
And that's not a thing that a lot of builders consider when they're selecting their materials.
Yep.
They think, oh, I need this to meet code. That's what I'm going to put on. Do I care about the fasteners? Oh, I don't even think the fasteners affect anything. So it's kind of shocking to see how much even just a little screw can do to affect the performance of the home.
The screw can screw you. I have found that from experience, it's a way for moisture to come in behind the insulation. The driving rain can find the screw. It's got a path to inside. It can travel along it. And in where we are, and Ed's in South Dakota, but where we get extremely cold, we've watched homes that have had rigid styrofoam nailed or screwed to the outside develop rot in circles following the exact pattern of where the screws were, because that cold thermal transfer was getting so cold, it was condensing and forming slowly over time moisture right at the sheathing level. Right.
Yeah, it's called a frost bulb when
you got it.
Get some frost on the end of the screw.
Absolutely. And then when you stick mechanical fasteners into fiberglass walls, then yeah, you're going to have frost balls on the inside of the bad insulation very easily. So one of the things that we told guys that were using rigid exterior insulation was absolutely go closed cell foam. We want to embed every single nail and staple and screw and metal fastener that's coming through the OSB or plywood sheeting. We want to embed them in foam and give you a fighting chance that these things aren't going to at least cause problems on the inside part of the wall. They can cause problems to the outside. So I fully agree with this, that the fasteners are a huge problem, not just because it's of lower thermal performance, but just the moisture issue of what we're talking about, building degradation. And that's for the cold climates, obviously, where it's a lot more temperate. It's not going to be as quickly as bad. So tell me about how we got to this. We've seen it on the internet, but this is variation number 3 or 4. Like, you've gone through a few of these. They used to be able to see through them. Now we're solid. So I mean, the spray foam can build. We're not trying to get foam inside open webbing. You got a solid web. You got the clips for the wires. Tell me about how you've gone about changing it as you go along.
On the first rendition of the X bracket, we did have that open web, and we had problems when the spray foam contractor was coming in to spray against those brackets. It would just shoot through and it wouldn't pile up like we had hoped.
Right.
So closing those up not only stopped the spray foam, it actually, when we ran the numbers, it gave it considerably more strength, which wasn't the reason why we did it, but it was a good product of that. The other main change is we changed the electrical clips. That's actually what these are. So you can clip electrical wires. You can use these in basement applications where you glue these brackets to the wall. Mm-hmm. These brackets actually have a proprietary glue strip on the back of these. Right. The adhesive squeezes into to form a mechanical bond, right, instead of relying on adhesion.
Right.
But these brackets or these clips, you can just go and snap wires into it. When you spray the foam in, the wires will be embedded to the foam. They're not going anywhere.
Right.
The other thing that you can do with these is, say you have a very old house that needs an electrical update, or maybe you're just wanting to do some minor electrical updates, add some boxes somewhere. If you're using these on the outside, you can actually do a large part of your electrical rough-in on the outside.
Oh, yeah.
It's actually going to be much quicker than drilling through studs, especially when you're talking about opening up walls to pull wires through. A lot less invasive. It's just a added benefit that can be very helpful and save a lot of time.
Now, one of the other things that's kind of unique to the brackets that you'll see is it has special little flanges on there, and people say, well, what are those for? And that's just to help prevent crossover water from going through the panels at all, and just make it so water can't run down one of these easily at all.
Okay.
And with the spray foam forming around there, it just gives an added benefit that hopefully is never needed.
Right.
Yeah.
So instead of getting, so the old-fashioned traditional method, if I wanted to put spray foam on the outside, was get like a Z-girt or some type of a metal bracket. But what I like about this is that you can have a box of these show up, boxes, and you're not dealing with a great big, huge, long bracket that's twisting and already isn't true, and you got to have 3 or 4 guys hanging onto it, and you got to snap a line. Like, this is This goes on really easy from people that have seen your videos. I mean, you're snapping out the line, marking where you want it to go. This is going up against the wall, and then you're using a nail gun or a screw gun. What do you prefer to use? Nail gun to put these on? So you can go right through the plastic quick?
I'd say if you can use a nail gun, use the nail gun. It'll be a little bit quicker than using the screws.
Right.
We do have an engineered code report that will help you select the fasteners that you use.
Oh yeah? Does it split this at all? Like, how's the plastic hold up? It's not pre-drilled or anything. Does anybody ask about that?
Yeah. So the polymer that we selected it's a very strong yet has enough elasticity in it to not split. And we've even thrown these in the deep freeze below zero.
Oh yeah.
Pulled them out and shot nails through them just fine.
Oh, you'd have to, yeah.
So if it's any colder than that, you're not even going to be thinking about spray foam.
Yeah. Well, installing the brackets is one thing, spraying the foam into it's another. But yeah, some guy like, let's crush this out and get this done. It's going to be real cold kind of thing. And yeah, it's good to know that they're not shattering like glass. So there's a lot of engineering people don't understand. Like, it's just like temper of a blade. Like, it can't be too hard, it can't be too soft, it's got to be too resilient. Mm-hmm. You must know about that, Ed, hey?
Yeah, and that's really the impact resistance on this is tremendous. You're going to find that, I mean, the typical frozen lumber is going to split, where it isn't the case with it. In fact, I mean, it's special proprietary, so we even had to build special molds and in order to be able to mold it. So it's not just any kind of plastic in there. It's really been tested and it's designed for the purpose.
This is 100% made in the USA. There's no China here. There's no Taiwan here. Eventually, you might want to come up to communist Canada and make a few up here, but we'll see if the CPP hasn't totally taken us over. But no, this is 100% made in the USA. Molding, plastics, suppliers, and everything like that, right?
Correct. There's no.
So how did it start going then? You've got the X bracket. You've gone through a bunch of different molding processes. There's a lot to know here. Like, there's engineering. There's testing. Tell me how that's been going, because now you're like, okay, it's a great idea. We can put this on the outside of the building. We can put spray foam, or we can do traditional insulation as well. But this is really a lot more geared towards a spray foam installation than it is traditional installations, right? Because it can go all the way around it. What took the next steps? There's a lot of work to go out there testing, certifying, seeing how it's going to go. That's a big giant to have to throw a stone at.
It is. It's a big barrier to small companies because it's a huge dollar amount for the product development, and to go along with the code testing, and they'll do the destructive testing on it so they know what the capabilities are and what the allowable loadings are for the bracket, and those are listed in the code report. We do have wind loadings in the 200 mile an hour range if you're wanting to work in the coastline and the coastal areas and so forth. But we really did an easy pass for the builder. There's a lot of products out there without support that need job-specific engineering, and we've come up with a generic engineering package that's suitable for virtually anywhere in the country. And it's something that there's no other system out there now that has that available to the contractor.
Right. So a box arrives, we snap the lines, we put the brackets on. The guy comes out, he spray foams to the outside of the envelope. Okay. Then what's next? Most people are like, okay, how do I finish the house off? I've got this bracket. Am I going to screw my siding direct to this? Like, how's it all going to work? What do I do next?
So before you install the spray foam, you're going to want to put furring strips on, whether that's wood furring strips or even metal hat channel or steel studs even will all work. And you can actually orient them in either the vertical direction or horizontal direction. So if you have a traditional lap siding, you're going to orient your furring strips vertically to just nail them into the furring strips. Or if you have a vertical, say board and batten or something like that, you can put the furring strips horizontally and attach the siding directly to the furring strips again. There are some things like you want to put cedar shakes or adhered stone or something like that. You are going to have to put something down first, but the majority of claddings will not require an extra layer.
Okay, so why the furring strips on before the spray foam? Curious.
There's a couple reasons for that. It actually helps spray foam contractor judge depth of foam a lot easier,
Okay.
and you won't have to do any trimming of the foam if you overspray.
Okay.
So that was a kind of hard lesson we learned on our first project. We were trimming some foam, and it would have been a lot easier the other way. And we have done multiple projects doing it with the furring strips on first, and that works a heck of a lot better.
Okay. Good to know. But I mean, you're going to get the bracket, and the bracket's going to be fairly deep compared to, like, it's going to be at least an inch deeper than the foam you desire to put on, I would think, right? Like if we're going for 3 inches, 75 millimeters, this is a 4-inch, 100 millimeter bracket. Just throwing it out there for an example.
Yeah, and that's exactly why we decided to go with that particular size. The one you're holding is the 3 3/4 inch bracket.
Okay.
It is designed to accept 3 inches of spray foam,
Right.
and leave a 3/4 inch air gap behind the furring strips. And one of the things that we haven't really gotten into yet is the rain screen that is created when you use this with the spray foam. You are going to be spraying the foam in, and then there's going to be an air gap between the cladding and the spray foam.
Yep.
That's going to allow for two things. It's going to allow bulk water to drain out the bottom.
Yep.
It's actually three things. It's going to allow air to move up through. It's going to act like a chimney. When the sun hits the building, it's going to naturally draw air up. And then it's also going to evaporate out any moisture that didn't drain out directly off the rain screen.
Right.
So actually allowing that extra 3/4 inch behind the furring strip allows air to move in either direction. Most of the time when people are putting the rain screen on, the common example is they're putting foam board on. They're doing 3/4 inch furring strips.
Yep.
When those furring strips run into, say, a window, it's blocking off that cavity in that rain screen, not allowing airflow through there around the window. So allowing it to move in both directions is really beneficial. One other thing that's unique about our system is that rain screen. If you decide to not only do the walls with this, but also do the roof with this, that rain screen wraps up over the roof. It's going to actually prevent roof leaks from causing damage. The other thing with that ventilation behind there is it's going to cool down the roof material and make that last longer. Asphalt shingles, if you install them directly over the foam board with the sheathing on top of it without any ventilation, they're going to bake in the sun and they just won't last as long. One of the other things that happens when you wrap it over top of the roof is, as opposed to spraying the underside of the roof, is that roof leak is going to shut off, not get trapped there by a vapor barrier. So it's not going to cause the damage that it would have if water became trapped between the roofing material and the spray foam. So.
Sure. Yeah, I think it's win-win. I mean, it's a commercial grade system like what we have seen for a long time with brick ties. You know, you put the brick tie is fastened and then the spray foam is placed over it, and then the tie and the cladding is an inch, 25 millimeters in front of the spray foam. And you know, Air Barrier Association of America has created a career out of how that works. And then similar things with the roof. You've got the ability to stand off and put your roofing. But at that point, you'd be putting the slats down, and then you'd probably be putting down full-on roofing sheeting at that point.
Yes.
So you need something to spray to, and then you need the actual roof decking. Those are two separate planes.
The only exception to that would be metal roofing. That can be placed directly on purlins.
Right. Exactly. Traditional shingles is going to need a solid backer all the way. I would be doing my next house with something like this for sure, because exterior insulation is just exactly everything that you said. It's better, it performs better, and then it's impervious with water. Absolutely, the spray foam is impervious, whether it's in the ground or external. So how have things been going with getting the word out, guys? Like, this is a year and a half now. We're just inside the 2-year mark. You guys have had your YouTube channel's gone from, slower to it's growing leaps and bounds, thousands of people every month. How are things been going with getting it out?
We have invested a lot into marketing, and it is starting to pay off. We are getting more and more sales every week and more happy customers. We have yet to have a customer complain about it. It's just been going great. We growth in leaps and bounds in the near future.
Absolutely. Yeah. Well, you've given so many options to the retrofit market as well, where you can be screwing this to the outside of the house or doing new construction. So you've got two different avenues. It's not just new builds that can benefit, it's the existing ones.
Yeah, you can take that house that's 100, 150, even 200 years old and bring it up well beyond modern standards. You can air seal that very leaky house very easily with that spray foam. That's the biggest challenge in those retrofits is air sealing. One thing that does need to happen when you start air sealing like that is you do have to bring in makeup air and stuff like that. So that is something to be mindful of when you're doing that. It can vastly improve the performance of a very old house. And one of the biggest holes, at least in the United States, I'm sure it's the same in Canada, in the housing market is bringing the old housing stocks up to par with the new stuff. It's a lot cheaper to do that, a lot more environmentally friendly to do that. And there are all sorts of government programs in the United States to help low-income families improve the energy efficiency of their home. And I think those are great programs that I think our government needs to fully endorse, because we're not going to solve the housing crisis without addressing the old stuff.
I think one of the things that's really exciting for us is when you take one of those old houses and you spray the foam all the way around it, you're adding another 100+ years of life to that home.
Yeah.
You're making it more durable. You're putting a protective shell around there. And the other thing is, too, whether it's existing or new construction, you look at how healthy a home is. When you build a house with super thick walls on it, if there's a roof leak or a plumbing leak or something, there is no heat to evaporate the water to get it out of there. It just stays in there and creates an issue. Now, with these houses being so tight, if you happen to have the asthma or allergy, now all of a sudden you can bring in fresh filtered air and control that environment and be comfortable in your environment that you're in, where you can't do that if you have a leaky home. So one of the things, the healthiest house you can build, Joe Stebrick, they have all the insulation on the outside. Then the other trick is you have your air, vapor, water, and thermal control air continuous from the foundation all the way up. I mean, whether it's water, and this happens to be spray foam, is the only thing that you can do every single control layer with one product.
Well, it allows you to flash everything, get it done in one sealed application where there's not multiple products that you're trying to get to form one function. You're using one product for one function, or multiple functions with one product.
Correct. Getting that continuity between all the control layers and intersections and so forth is something that spray foam just does naturally.
Naturally, yeah.
You're having a professional come in and spray the foam and get it. It's not something where you struggle with labor to try to roll tape properly or seal this or add another layer of something. There's nothing bad that happens in the center of a sheet of plywood. It's always at a joint. It's always a connection. You have a window in there or something that leaks water. When you have a continuous monolithic layer of foam around there, you've done it. So
exactly. He just sold the spray foam for us. Like, that's the red pill moment. What Ed's just describing is what I had with foam. It's like, goodness sakes, why would I want to use a product unless I absolutely had to, that had all these seams, right? I want to get what you just described. I need more foam, not a problem. I'll just add it on. It's liquid. You guys are both got pictures of containers, behind you. You're sitting in a container office there, Matt, and you've got container behind you. Tell me about the container craze. People have been using shipping containers for everything: housing, shops, woodworking facilities. They want to build everything out of them. This has an amazing fit with the container people from inside or outside, right? You got pictures right there, Ed, behind you of outside. I like that.
The most exciting thing about the outside of the container is you get a 100-degree day out, and that metal on that container, it's like a car, it gets to 140 degrees. So that's what your heating is, going through the heat flow going through there. You're trying to air condition that container. Now all of a sudden you put this on the outside, and then you put siding on the outside. You have a ventilated airflow rain screen in there. It's like bringing your container into the shade. So instead of
Right.
seeing the 140-degree heat load on there, it's the outside of the foam sees the 100-degree heat load. So you've cut it down by more than half when you're trying to get down to 70 or degrees or 75 degrees inside. So it makes a lot of sense.
And one other benefit of putting it on the outside, like actually this container that I'm sitting in now, is containers, generally speaking, have a 30 to 40-year lifespan before the corrosion and rust affects the structure and air tightness and water tightness. And when you put all this on the outside, this ventilated rain screen, the spray foam, actually the perfect vapor barrier,
Yeah.
it's going to increase the lifespan of the structure 2 or 3 times that, if not more.
Right.
Because you're encasing it and protecting it. And the same can be said for traditionally framed homes. When you encase it and protect it from moisture infiltration, you don't get rotted out studs without moisture infiltration.
Right.
I guess the exception to that is condensation, but this will also prevent the condensation.
No, I agree. No, your number one problem is moisture to the outside, for sure. There's 2 envelopes going on, your inside one, your outside one, but your outside one's going to take you down a whole lot faster.
Yep.
Unlimited ability to be encountering rain and all these issues, whereas condensation, just the right amount of climatic conditions have to align in order for that to stay. But hey, if it's rained 4 days this week and the rain came in every single time it was raining, you're going to be in a world of hurt fairly soon.
Mm-hmm.
So the container crowd is definitely geared towards using these. In fact, I can think of a couple of manufacturing groups that we've dealt with from time to time. They need to know about this, because what they're doing is they're putting industrial equipment into the containers, and up until now they've always been using steel brackets to try and get some sort of a lining inside roof and walls to put the inside tin on. So what they'll do is they'll put the brackets on, we come in, spray foam, shave everything down, make sure it's good, then they tin line the inside. I think this is something that they should definitely be seeing about. I'll be definitely talking to them about it, make sure they know it exists. And with the glue, you guys can glue it on. So when you don't need to screw it, you can glue it, right? A little bit of a rhyme, right?
Yeah.
So this can go on concrete and metal as well. And you've been doing this for basements and concrete systems as well.
Yep. We had projects in both applications with that, and we have both those attachment methods written into our code report as well. So all the engineering that you could possibly ask for is in that code report.
So how does that work, Matt? You're very quickly needing almost a building envelope department where you can advise people, and you've got somebody almost on staff that can say, here's how to do it, or you should do this. Because I bet you there's some people that phone up with some crazy ideas about what they want to build, and they're like, yeah, I want to hang the whole entire car off the X bracket once I get it up there. And you're like, no, that's not what we're going to be doing with it.
Yeah, I'm actually kind of that person who deals with those more technical building science questions. And one of the cool things about our company is you call us, we're going to answer the phone, and you're going to be talking to a real person.
Right.
So no robocalls or anything like that. If you need help, we give you help. And we have all sorts of customers call in with asking for advice on what type of WRB to use, or how to use the X brackets, what spacing they need to select, all that sort of stuff. We help them out with.
One of the things with the building science, if you put everything on the outside, it will work from the Arctic down to the hot, humid Florida.
Absolutely.
You'll never have a vapor barrier side. It will be suitable for any time of the year. And that's something with building construction that you'll do the exact opposite in a hot, humid versus the Arctic or the Canadian climate. So you're always going to have in there where your building's taking on moisture, where you do have more possibility And that's where the healthier home, the more exterior insulation there is. And there's actually some things that change if you do all the insulation on the outside.
Mm-hmm.
The coldest spot where the framing was and the windows and the corners are all now your warmest spot because they have extra insulation in it. It just changes the rules of construction.
Oh, absolutely. I totally agree. The next structure, if I was to do another house again, that's exactly how it would be sprayed to the outside, for sure. And then put some slats on and then have the exterior siding or whatever material I'm going to finish the house with, brick or what have you,
Yeah.
would be done to the outside. So you guys have managed to pick up some pretty high-profile attention. Matt Reisinger's featured this a couple of times on his channel. Tell us about how that's gone and just it's increased sales and helped things out, I would imagine.
Matt's definitely helped out. I mean, the neat thing about Matt is he's a real world contractor. I mean, we both come from the same background and we have the same issues in the construction, the durability, the liability of doing things wrong and how to do things right. I mean, there's a lot of products out that aren't attainable for the everyday market.
Oh, yeah.
That
Good point.
we're not all building $4 million homes. And the exciting thing about this and working with people like Joe Stebrick and the Cold Climate Housing Development Minnesota and also South Dakota Architectural Department in these northern climates and so forth, it's really something where the expertise and the prescription is exterior insulation. And then it's also airflow and movement. It's getting continuity between all the control layers. And it's really something that we talk about in the northern climates, but it's also the southern climates where you start looking at air conditioning as the biggest cost. And it's just really coming down to a comfort issue now. You start out at the mobile home comfort wise, and then you move into an older home and you're got a different comfort in there. Then you go to a new home and you keep saying, well, I wish I had it built like the new home, or now you can go to the net zero and then you'll have, instead of 4 degrees temperature difference around a room, now you're down to about 1.5 degrees or 2 degrees. Until you experience that, until you experience how quiet it is, it's something that until you have it, you don't realize what it's like.
Oh, yeah. That's fine. I've said that with spray foam. Like I've said that for years, that you're looking at the bill, what the bill's going to be, and you don't realize it until you've actually said, oh, all right, let's give this a try. And then as long as the spray foam is installed correctly, you've got a salesman for life, because they're generally going to see how well everything works and experience the comfort, the low consumption and everything like that. And they'll keep telling all their friends about it. Ed, you said something there that is very powerful. I don't know if the audience picked up on it. I'm going to reiterate it again here, is that you're giving high performance that's obtainable to the average person. Some of the products you said are going to be fitted out for a $4 million home, $2 million home, whatever it's going to be. This is giving you that $4 million performance without the price tag. So you're going to be able to incorporate this into a build, but it's obtainable from everybody at the lower end all the way to the upper end. And I think that's exactly what we need right now.
The existing housing market is the most cost-effective way to upgrade it and bring it to any performance level and add that durability. But yeah, that's what's exciting is you can't retrofit one of these old houses without multiple layers of fluid applied waterproofing, getting special air seals and so forth to go around everything. To do, it's very, very difficult when you have board sheathing. You can't seal that board sheathing at all. It's virtually impossible to do with any kind of membrane because it will just blow right behind it.
Yep.
The spray foam does a remarkable job at a remarkable cost. When you start looking at that, well, big spray foam budget, what I really challenge people to do is look at that, what that big spray foam budget can do. If you put that insulation on the outside of the home, you're going to get 25% more performance out of it, up to, if you're doing a real energy efficient house, I mean, it's even up to 50% more than if you did it in the cavity. So you get what you pay for in this. You're getting all the R value that you paid for, and you can't say that with cavity insulation.
Yeah, and you maximize it. So what's the future hold for the X bracket? Where do you guys see this going? Because I see this as something that potentially, could I go to Home Depot one day and buy it? Do you think? Is that your goal, or where do you want to take this?
We are hoping to grow a distribution network. Right now, we're shipping direct to customer. We are hoping to be able to get into larger building supply distributors. And one of the other things I don't think that we mentioned yet, as we're talking about future, is we are coming out with larger sizes of X bracket too, up to 9.5 inches. So if we're talking the passive houses or roof applications where you need to meet a very high code limit, we are going to be expanding our product offering hopefully this fall.
Yeah, exactly. I mean, there's a valiant effort right now to get spray foam recognized for what it can do with the air tightness and stuff like that. So we don't need to put as much in. But until those days come, it's very much needed. And even still, there's some people that just want 6 or 7 or 8 inches. That's what they want. So fine, we'll make a bracket and sell it to them if you want, or need it. Or maybe you need to overcome something. There's something on the roof that you need more depth to deal with. Yeah, I think it's a great idea. One of the things that I told some of the builders that we've worked with is, like, if you want to do framing drop downs, like we've done a lot of drop downs where you have a bedroom or something or a living space that's over top of a cold zone. So they're going to have to do a drop down insulated envelope underneath that floor. I said, this is a perfect way to reincorporate how we want to do the framing, underneath there is you've now got a tool in the toolbox. I think the X bracket is amazing on what it can incorporate into for framing details and drop down details.
The X bracket isn't even limited to those. It can also be used on top of the floor as well. It has a very impressive strength of nearly 2,000 pounds per bracket. Actually, the floor that I'm sitting on now is framed with X brackets, and it's very sturdy floor, very well insulated floor. That's just one of the other aspects of versatility in our system.
That brings up a good point, because I've had a lot of guys, like spray guys, listening to this. I've had a lot of people that have got rental properties, and what they've done is they've wanted to expand a suite. So they'll take the garage and convert it into living space. And so the whole house has got somewhere to rent. So they'll put another door and put a kitchen in. But what they're doing is they've got a cold cement floor. So they wanted us to come in and do spray foam. Then what they've done is they've hung floor joists inside the floor. So they've got a little miniature crawl space in there. But the first thing we do is we come in and bowl that out and put spray foam. X bracket would be perfect. I mean, they could use furring strips to level things up. They could go right to the existing concrete floor, put the brackets in place, foam them in place, and then put their flooring material on. That would be a really good way to go.
One of the things it does too is it softens up that floor. If you're used to being on a hard concrete floor, it makes a huge difference, and it really brings another level of comfort to that concrete, not just in the thermal sense.
Oh, absolutely. Absolutely. Yeah, nobody wants to be walking on the concrete all the time, tear up your knees. Well, guys, I think this is an amazing product. It's a friend of spray foam. Spray foam and this are a match made in heaven, and so many guys want to know more about it. So where are people going to find all the information? They're finding you on the web. You got a YouTube channel, which is prevalent. You guys are on multiple different platforms, and you got your website. Tell us about how we're finding you.
We are on most social media. Our website is www.insofast.com. You can even call us over the phone if you have questions about it.
Right on. So is there anything that I'm missing today that you wanted to talk about? Anything else, other applications or unique projects that you wanted to chat about?
One of the things that we mentioned, shipping containers and doing the outside. And that's always a question. What about condensation and so forth? Well, the shipping container, if you have all the insulation on the outside, that steel is the same temperature as it is inside.
Yep.
So there is no condensation. Now, the other thing is, if you can leave the shipping container and use it as a finish, you're way ahead of things as well. But if you want drywall, you could literally do drywall screws and put drywall on, because you have everything sealed on the outside, and then you're not losing 8 inches of space on the inside of that container. And
oh, absolutely.
if you're having to build to a code and do R20 insulation or whatever, doing that on the inside or outside with spray foam is a lot thinner profile than what you can get with other things. And for the container, you have to have the closed cell if you do it on the inside, because there is no way to keep that moisture from condensating. You don't want air. The neat thing about the spray foam is it bonds right to the steel. You don't have any airflow or anything behind there.
Absolutely. The adhesion of the spray foam to the substrate is one of its greatest attributes. People don't realize that when you've got insulation that's just laying in up against it, how many issues that can reintroduce. Its effectiveness and where moisture can sit. So that bonded, I tell a lot of people, you're not paying for us to give you a perfectly even, smooth spray foam. That's not what you're paying for. You're not paying for the top end. You're paying for that bottom end. You're paying for what you don't see, which is that adhesion to the substrate. Because it's going to have tight, intimate contact means that you're not going to have much loss. ASHRAE manual was saying that a 3% void, 3% for whatever the thickness of the insulation is, accounted for a 15% reduction in the insulation's ability to do its job. So if you had a 3% void, it was a 15% reduction in how well it would work. So it adds up very quickly.
That's just to say, I mean, the spray foam, you get a nice tight seal all sides, and you don't have that installer issue with how good they're fitting everything. It's a perfect fit every time.
Right on. Well, thanks, guys. Am I missing anything? Matt, did you have anything else that I missed that you wanted to chat about?
I think we hit everything that we wanted to talk about. So
Perfect. Well, guys, thanks for coming on. Thanks for telling us about this. It's going to be so interesting to be watching your careers grow and Insofast grow and the X bracket grow. And we're trying to bring more awareness into the spray foam industry, what products are out there, what building envelope products, anything to do with foam and peripheral to them. So it was just a great pleasure to have you on and chatting with this and bringing edification to the industry. So thank you, both of you, for coming on here today and having a chat with me.
yeah, thanks for having us.
Thank you, Mott.
Yeah, you're welcome.